Hi everybody, in this video I want to show you how we can revolve a line or a curve around the x-axis to create a volume of revolution. This is a really important idea in calculus as it helps us to understand how to find the volumes of complex shapes. So let's start with a simple example. Here we've got the graph of a line y equals 2x plus 5. Now imagine if we take this line and revolve it around the x-axis. By doing this we create a three-dimensional shape. And this process of revolving the line 360 degrees or 2 pi radians around the x-axis creates what we call a solid of revolution. When we revolve a line around the x-axis, every point on the line traces out a circle in the xy plane. So the distance from the x-axis to any point on the line gives us the radius of these circles. So the line y equals 2x plus 5 becomes the radius of the circle. So to work out the volume of this solid, we need the volume of a cylinder. And this is pi multiplied by the radius squared. And remember that the radius is the distance from the x-axis to the line, multiplied by the length of a cylinder. Now I've called the length of a cylinder delta x, because what we're going to do is we're going to pack this solid full of discs with an almost negligible length. So this delta x is very, very small. And the radius will be the corresponding y value for x at that point. So if we call this radius y1, y2 and y3, then we can find the volume of this solid by adding up the volume of each disk. So the first disk will have a volume of delta v1, which is this disk. This will equal pi times the radius, which is the y1 value, squared, multiplied by the depth, which is delta x. The second disk will have a volume of delta v2, which will equal pi times y2 squared, multiplied by the same depth of delta x. And the third disk will have a volume of delta v3, this will equal pi times y3 squared delta x. So the volume of the entire solid will have a volume of delta v1 plus delta v2 delta v3, and remember that this is full with an infinite number of these very tiny disks. So this will continue forever. And now we can replace each of these volumes with its corresponding equation. So the volume will be pi times y1 squared delta x plus pi times y2 squared delta x plus pi times y3 squared delta x. And this would go on until we reach the limit of our solid. When we add up these tiny changes in x, this is exactly what integration does. It is a summation of tiny changes in x within a certain range. And we can rewrite this as the volume will equal to the summation of pi multiplied by these y values. And the y values all lie along this line. And because they're squared, we'll say y squared times delta x. And when we integrate, this delta x becomes dx. And this pi is just a constant. So we can move this constant out in front of our integral sign. So the volume will be pi times the integral of y squared with respect to x. And you can see in this example, we have a limit of x equaling 1 and x equaling 5. So we'll include this on our integral sign between 1 to 5. And we're told that y equals 2x plus 5. And therefore, the volume will be pi integrated between 1 to 5 of 2x plus 5 all squared, integrated with respect to x. Now we can expand out these brackets, so the volume will be pi times the integral of 4x squared plus 20x plus 25. We'll put this in brackets, and this is integrated with respect to x between 1 to 5. We can integrate this expression, so a volume will be pi multiplied by 4 over 3 x cubed. The 20x, when we integrate, becomes 20x squared over 2, so plus 10x squared plus 25x between our limits. And I can work this out on our calculators. So we'll substitute our upper limit into the expression. So when I substitute this 5 into this expression, I find it much easier to store 5 as the previous answer, because now all I have to do is 4 over 3 times the previous answer, 5, to the power of 3, plus 10 lots of the answer, 5 squared, plus 25 lots of the answer. So this just makes it much easier for me to substitute the 5 into the expression. And we'll equal this, so we get the volume will be pi times 1625 over 3. And then when we substitute in this 1, well, all the x's become 1. So we've got minus 4/3 plus 10 plus 25. So 109 over 3. We can work this out. So 1625 over 3 minus that previous answer, and we get the volume will be 1516 over 3 multiplied by pi, and this is in units cubed. Okay?